because I'm speaking to the Reading Geological Society, I'd like to take as my starting point Thomas Harris, FRS, who was Professor of Botany at the University of Reading from 1934 to 1968. And I'm guessing that some people on the call might remember Tom Harris. Well, in 1956, he did a broadcast on BBC Radio with the title The Mystery of Flowering Plants. And this was about Darwin's Abominable Mystery. Perhaps some of you even remember listening to this broadcast, I don't know. It was published afterwards in The Listener magazine. And in it, in this transcript of his broadcast, Harris began with these words. People began to study fossil plants scientifically soon after 1800. By 1850, they had learned a great deal, and they already knew that they could trace the flowering plants back for a long way, and that then they suddenly ceased. They suddenly ceased in the fossil record. Charles Darwin, writing about this time, called the sudden development of the flowering plants an abominable mystery. Since then, many have tried to solve this mystery. We have sometimes thought the solution was at hand, but the mystery remains. Then he goes on, the mystery is where they came from and why they burst forth everywhere in considerable variety. What we would have expected is gradual evolution from some gymnosperm family and a gradual rise to importance. It is because the facts are just the reverse that the mystery seems abominable. People have tried to solve this problem in several ways. Pure thought has given us some rather beautiful theories of the nature and origin of flowering plants, theories which seem more akin to poetry than science. Then he turns to paleobotany and says, the fossil botanists have looked in the rocks and their reward has not been the answer they sought, but a number of queer and unexpected kinds of plants, each a problem in itself. However, I think they have good reasons to continue hopeful. We have recently learned a great deal about the history of the ferns and of the conifers, and why not the flowering plants presently. So he strikes quite an optimistic note as he describes the ongoing nature of Darwin's abominable mystery. And he sees it very much in terms of the origin of the angiosperms. And for those of you who are not botanists or paleobotanists, just a quick reminder of things that you may well have learned in school. The angiosperms, or the flowering plants, have commonly been split into the dicotyledons and the monocotyledons. So the dicots are things like roses and sunflowers and apples and ash trees. The monocots are things like orchids and wheat and barley, grasses, bananas, etc. And the angiosperms contrast to the gymnosperms. The gymnosperms include things like coniferous trees. So the gymnosperms have a very, very long fossil record, but the angiosperms appear very suddenly in the Cretaceous. And how big a difference is that, the difference between gymnosperms and angiosperms? Well, it's quite a considerable difference. So angiosperms are the only things that have true flowers. Gymnosperms tend to have cones or other reproductive organs. Gymnosperms tend to have separate male and female cones, whereas angiosperms often have combined sexes in a flower, although they don't always. These are just very big generalizations. Gymnosperms have many cotyledons or seed leaves, as they're sometimes called. Monocots have one cotyledon, which is where they get their name from. Dicots have two cotyledons, which is where they get their name from. One key difference is gymnosperms have a naked ovule. That's what the Greek means of gymnosperm. Whereas the angiosperms have an enclosed ovule. It has a carpel that encloses it. So the origin of the carpel is a very important issue in the origin of the angiosperms. And then there are various other differences that are sometimes or more often found. But one key thing I've got at the very bottom of this table, there are not many species of gymnosperms, but there are huge numbers of species of angiosperms present in the world today. And recent estimates would put the number of angiosperms at well over 300,000 species. So tremendous biological diversity there in the angiosperms. So what we're talking about when we say Darwin's abominable mystery is how the angiosperms suddenly appeared in the fossil record in the Cretaceous. Here's another talk by Tom Harris. This is to his fellow scientists in 1960, 4 years after his BBC address, speaking at the Botany section of the British Association on the origin of angiosperms. And he starts off like this: presidents are given to reviewing their subjects broadly, and their audience must half expect to be made to look backwards on past achievement. And I think this is no bad thing on rare occasions. But I ask you to look back not on a proud record of the success of famous men, but on an unbroken record of failure. And I think it will be kinder if I leave out the names of the famous men concerned. It is indeed a record of vigorous and even gallant failure, and of what seemed heartening discoveries that were perhaps only proved irrelevant many years later after the discoverer's death. And then after a while he said, now you may remember that this problem worried Darwin, and I suppose a lecturer in 1860 would have summarized knowledge in almost the words I now use. Fossil angiosperms, or flowering plants, are abundant and familiar. We can trace them back with ease in suitable rocks as far as the Cretaceous period, and then a little above the middle of the Cretaceous, there are none, or very few, virtually none. He goes on to say, there have been a dozen candidates as early angiosperms. There may have been a dozen candidates as early angiosperms in 1860, and probably all are exploded and forgotten, and many that have been exploded since. And these are among the respectable fossils of other classes described in textbooks. There may be a dozen candidates today whose fate is undecided. I would be surprised if all gain admittance. And just to give a couple of examples of some of these exploded early angiosperms, perhaps the most famous one is one called Caytonia. Now, Caytonia was discovered by Hamshaw Thomas in the Jurassic rocks of Yorkshire. He was a Cambridge academic, and in 1925, he published a very famous paper where he drew the fruit of Caytonia, and remarkably, it had an enclosed ovule. And he said, therefore, this must be an angiosperm. It's not a gymnosperm. It doesn't have naked ovules. They are enclosed. Therefore, by definition, it is an angiosperm. And this became a classic example of an early angiosperm, and was commonly seen as the missing link between gymnosperms and angiosperms. However, Tom Harris discovered some Caytonia in Greenland a few years afterwards, and his fossils were rather better preserved. And he found that, in fact, they don't have enclosed ovules. The ovules are actually open to the elements, and therefore it's actually a gymnosperm. And then this became commonly accepted. So Tom Harris had himself exploded, to use his own term, one of the major hoped for solutions to the abominable mystery. And when he wrote the obituary of Hugh Hamshaw Thomas when he died in the 1960s, Tom Harris reminisced about what had happened about Caytonia. He says the Caytonia paper of 1925 was Thomas's greatest. He wrote with enthusiasm, and well he might, for he had reason to believe that he had solved the age-old problem of fossil botany, the origin of the flowering plants. This class is distinguished by a dozen characters, of which the closed ovary is outstanding, and it gives them their name angiosperms. Thomas's fossils were closed, berry-like ovaries. This indeed he knew in 1912, but by 1925 he had done much more, for he had recognized both the leaves and the pollen-producing organs of these plants. And this synthesis was an outstanding piece of botanical detective work, comparable with that which gave us the first pteridosperm. He later said, he was also delighted to find pollen agreeing with that of his pollen organ on the stigma-like mouth of the fruit. I was a student in the botany school, that's at Cambridge, at the time, and I remember a ripple of excitement reaching me when he made this discovery. So at the time, people thought that Thomas had actually found pollen in the act of fertilizing a carpel on a Caytonia. Caytonia had been caught in the act of reproduction, and this seemed to prove that it really was an angiosperm. And so you can imagine all the excitement that there was, that this mystery was solved in one swoop. But unfortunately, it wasn't to be because of Harris's later discovery. So you can imagine why Harris feels quite personally about this whole issue of Darwin's abominable mystery when he spoke on the BBC in 1956. Just another brief example of an exploded early angiosperm hope is that of pollen. Back in 1925, people had quite limited capacity to look at fossil pollen, but in the 30s and 40s, there was a great growth in palynology. And there were many hopes that angiosperm pollen would be found, even though other angiosperm fossils had not been found. And so in his BBC broadcast, Harris said this: people have reported flowering plant-like pollen from several places in rocks of Jurassic age. I would mention the discovery of grains like those of the white water lily from northeast Scotland. Grains of various other kinds have been discovered in Sweden and Germany. When these grains were first described a few years ago, I thought, at last we have the answer. The flowering plants were present in variety and widespread, but they were not being preserved as ordinary fossils because they did not grow in the right place. The Cretaceous floral revolution was just a small one, I thought. The flowering plants just moved from the background, say the dry hillsides, to the foreground, the riverside swamps. But I rejoiced too soon. The pollen grains have been examined by others who declare that they are not flowering plant grains at all, but just gymnosperm pollen and fern spores. So there's another example of several that he gives of exploded early angiosperms that had got his hopes up that the mystery was solved over his long career, but had proved to be spurious. And as he closed his address in 1960 at the British Association, he said, "Nothing, I'm afraid, will make a neat summary of this rambling address. I have no recipe for success. Hard work may give us what we want, but so far it has not. But where the work has been scholarly, it has given its own reward by adding to knowledge of some unexpected and strange plants. In fact, when I see a claim from someone to have an early angiosperm, I have a feeling almost of compassion based on the statistics of earlier claims. We want early angiosperms urgently, almost as a thirsty man wants water. And like the thirsty man, we're not critical about the quality of the water, nor should we be, but then we should look again at the evidence as a well-dined man looks at water." So he's saying that his long career of disappointments about early angiosperms has led him to be very skeptical of any new claims that early angiosperms have been found before the Cretaceous, but he really, really wants to find some. So I think if we can conclude anything from this, it is this, that the abominable mystery was definitely alive and well in 1960, according to Professor Thomas Harris. One question I want to ask, though, is, was Harris correct that the problem was the same in 1960 as it was for Darwin in Darwin's lifetime? And you can see why he thought it was the same as in 1960 as it was for Darwin, because his access to Darwin's original statement about the abominable mystery was a letter that Darwin wrote that was published in 1903 in a volume that was edited by Darwin's son Francis and by Albert Sayward. And Albert Sayward was an academic at Cambridge who'd actually got Tom Harris started off in paleobotany and sent him to Greenland, where he found Caytonia. And in this volume of Darwin's letters, the letter where Darwin writes, "I have just read Ball's essay. It is pretty bold. The rapid development, as far as we can judge, of all the higher plants within recent geological times is an abominable mystery." Now, if anyone had any doubts about whether by the higher plants Darwin meant the Angiosperms, the editors sort of took away all doubts by placing at the top of the page, "Evolution of Angiosperms." So although Darwin himself didn't use the term angiosperm, the editors placed it very prominently there. And any reader would think, oh, well, this Darwin was definitely referring to the angiosperms. And just to make it even more clear, in a footnote in the same book, the editors wrote, "No satisfactory evidence has been brought forward of the occurrence of fossil angiosperms in pre-Cretaceous rocks. The origin of the monocotyledons and dicotyledons remains one of the most difficult and attractive problems of paleobotany." So in 1903, the editors were very sure that this was about angiosperms. And indeed, the problem at the time was a problem of the angiosperms. The angiosperms were seen at the time as appearing very suddenly in the Cretaceous. However, when I started reading some of Darwin's other letters in the 1870s, I noticed that when Darwin was more specific about the problem, he didn't write about the angiosperms, he wrote about the dicotyledons. For example, here's a letter he wrote to Oswald Heer, a Swiss paleontologist. He wrote, "The sudden appearance of so many dicotyledons in the upper chalk appears to me a most perplexing phenomenon to all who believe in any form of evolution, especially those who believe in extremely gradual evolution. I fully admit that this case is a great difficulty in the views which I hold." So why was Darwin writing about dicotyledons and not about angiosperms? Well, it turns out that at the time, many classifications of plants didn't have a single category called angiosperms. For example, here's the classification of Bentham and Hooker, and Darwin was actually writing his abominable mystery letter to Hooker in 1879. And the Bentham and Hooker system has a class of dicotyledons, a class of gymnosperms, and a class of monocotyledons. And the gymnosperms fall between the dicotyledons and the monocotyledons. So they didn't have a group called the angiosperms. Other classifications were similar, but actually lumped the gymnosperms in with the dicotyledons. Although Darwin definitely wasn't referring to the gymnosperms as well. We can see that from the context of his letter. And then other publications from around the same time show the understanding of the fossil record at the time, and that is the dicots appeared suddenly in the Cretaceous, but the monocotyledons had a much longer fossil record going right back to the Permian or the Carboniferous. And that was because they were mistaken in the identity of some of the fossils which they found. And it was only after the 1880s that these were correctly identified. And so by 1903, when Darwin's letter was first published, the scientific consensus was that all angiosperms appear in the Cretaceous. And this understanding of the fossil record got read back into Darwin's 1879 letter. So for Darwin, the mystery was actually slightly smaller in 1879 than it was in 1903, when his letter was first published. And I wrote a little piece about this called The Deepening of Darwin's Abominable Mystery. That was published in 2017 in Nature, Ecology and Evolution. And I just pointed out that Darwin did understand the mystery somewhat differently to later scientists. And in fact, the problem has got bigger rather than smaller in the years between 1879 and 1903. I delved into this issue further in my recent paper in American Journal of Botany, if you want any more details about this issue and any more proof that that is the case. Another very interesting thing I stumbled on when I was doing this research on Darwin's understanding of the mystery was a hint at what perhaps made the mystery so abominable to him. Why did he call it an abominable mystery? Why did he feel so strongly about it? Well, it turns out that on November the 6th, 1876, when Darwin opened the Times newspaper after lunch, as he always did, he came across a headline, Plant Evolution, and then quite a long article, which I've just shown a couple of extracts here. Plant Evolution, Mr. W. Carruthers, FRS, the keeper of the Botanical Department of the British Museum, delivered as president an address to the members of the Geological Association on Friday evening. It was almost wholly occupied with a comparison of the theory of the evolution of plants as set forth by Haeckel and the actual record of the rocks so far as we presently know it. And when he gets on to the issue of dicots, he said, dicotyledonous plants made their appearance in strata which are referred to the Upper Cretaceous series. No trace of the division has yet been detected in any earlier stratum. And then he went on to say, to argue that the absence of the dicots could only be because they really were not present in the world. And if they had been present, we would have expected to have seen them captured in the fossil record, because there were other plants that we would expect to have similar capacity for preservation in the fossil record that were preserved. And so it seems strange if dicots were there and were not. And he also points out that there are no intermediate forms between dicots and the plants which were existing in the fossil record in the Jurassic. So here Darwin was reading in the Times a very high profile attack on evolution by an expert in paleobotany, quoting the plant fossil record in support of his views. And he was someone who had much more authority to talk about the fossil record than Darwin or any of Darwin's allies. And this was William Carruthers, the keeper of botany. And of course, the botany collection at the Natural History Museum is very rich in fossil plants, and that is a great strength of the collection in the Natural History Museum, even to today. Carruthers then did a great deal more to publicize his lecture. It got published in a couple of other publications, one of which was the Gardener's Chronicle, and Darwin kept a cutting of the article in the Gardener's Chronicle. And Carruthers also published it as a booklet, which was a reprint of the write-up that he published in the Proceedings of the Geological Association. And the reprint was called Fossil Plants and Their Testimony in Reference to the Doctrine of Evolution. And this is the copy that we have in the library at Kew, and it was sent to Miles Barclay, who was the person who identified the fungi from the voyage of the Beagle, very close ally of Joseph Hooker, the director of Kew. And at the end of this article in the Proceedings of the Geological Association, Carruthers was even more outspoken and said things which would actually be even more objectionable to Darwin. He said, the facts of paleontological botany are opposed to evolution, but they testify to development, to progress from lower to higher types. And then he goes on to say, development is not the property of the evolutionist. Indeed, the Mosaic narrative, the oldest scheme of creation, which traces all nature to a supernatural creator, represents the operation of that creator as having been carried out in a series of developments. And when he closes, he says, the rocks record the existence of the plants and animal forms, but as yet they have disclosed nothing whatever as to how these forms originated. So he's strongly suggesting that the dicots in the Cretaceous had a miraculous origin. He seems to be taking a view which is essentially an old Earth creationist view, that the fossil record is an accurate representation of a very long period of time, interspersed with episodes of creation. This, of course, would be absolutely anathema to Darwin. You know, decades before, Charles Lyell had said that he wanted to free geology of Moses. And here, Carruthers was very explicitly bringing Moses back in. If you want to read more about this, again, it's in the article I published earlier this year in American Journal of Botany on the origin of Darwin's abominable mystery. So that adds a bit more colour to the debates that were going on in Darwin's lifetime. Now, I want to come on to the question that I'm sure everyone is asking. Has the abominable mystery been solved since Tom Harris's 1956 broadcast? It certainly seemed to be alive and kicking at the time. Is it still alive and kicking today? Well, shortly after the two talks by Tom Harris, younger paleobotanists came up with a radical new approach to the plant fossil record. In Tom Harris's generation, everyone had assumed that they were correct in their attributions of the Cretaceous angiosperms, and very commonly they were finding isolated leaves, which were then being allocated sometimes to a modern genus or sometimes to a modern family. So it seemed very clear that a lot of evolution must have happened before these modern families or genera were appearing in the Cretaceous. And that suggested, of course, a much longer fossil record. But after all of these exploded early angiosperms in the Jurassic, people started to come up with a radical new approach. And they said, well, perhaps we should be looking within the Cretaceous itself for the evolution of the angiosperms. And they said, well, let's get rid of all of these names of the fossils that suggest they belong to modern families or genera. And let's just treat them as they are, as ancient leaves or ancient pollen grains. And then let's try to piece together an evolutionary series out of them just as they are. And so one of the great examples of this is a study by Hickey and Doyle in the Potomac Formation on the east coast of the USA. And they pieced together a very detailed dating of the formation, and then studied the leaves and the pollen that they were finding. And whereas in the past, paleobotanists would have looked at a leaf like this and said, well, that maybe belongs to a poplar, or this belongs to a maple, or this belongs to a lime tree, etc., etc. They said, no, we're not going to do that. We're just going to look at the shapes and the form of them and come up with an evolutionary series. And that is exactly what they did. And so they said, our first and most important conclusion is that the primary adaptive radiation of the flowering plants took place during the early Cretaceous. And this seemed to solve the problem, basically. They said, you know, we've been wasting our time looking in the Jurassic for angiosperms. Actually, we had the evidence before us all this time. We were just giving the wrong names to the fossils that made us think they weren't what they really are. And this was very appealing. It did require pretty rapid evolution, perhaps more rapid than Darwin himself would have wanted, but it did seem to be a novel solution to the problem. However, it didn't last all that long, because in the 1980s and the 1990s, new methods were developed for extracting very small fossil flowers from clay. And quite often these fossils were charcoalified, and they would be excavated by lots of washing and sieving and then examined under electron microscopes. And here's an example of one. It's in the late Albian, so it's in the mid-Cretaceous, and it's very clearly the flower of an angiosperm. And when its different characters are analyzed, it turns out not to be a particularly primitive angiosperm at all, but one well into the eudicots. That's further from the root lineages of the angiosperms. So it's very difficult to see it as a primitive angiosperm. And so the discovery of many, many different tiny fossil flowers in the mid and even in the early Cretaceous meant that this view of the fossil record that said, well, the whole of the primary adaptive radiation of the angiosperms took place in the early Cretaceous just couldn't really be held anymore. Furthermore, we had the origin of molecular phylogenetics as well. And so the origin of the angiosperms could be explored not just by looking at fossils, but also by looking at the DNA and building phylogenies based on extant angiosperms. And here's quite a recent paper published in Nature Plants on the origin of angiosperms and the puzzle of the Jurassic gap. And like many other molecular phylogenetic studies, this reconstructs the origin of the angiosperms as being far back in the Jurassic or even the Triassic. And it's got the split of angiosperms from gymnosperms happening in the Carboniferous. And you can see that by the start of the Cretaceous is shown here in green, by the start of the Cretaceous, you've already got many major angiosperm lineages already present. Now, if this is correct, then you would expect to see lots, or at least a fair number of angiosperm fossils in the Jurassic and perhaps even the Triassic. And again, it opens up the question, well, why don't we see these in the fossil record? And it doesn't fit well with a view that the primary radiation of the angiosperms took place in the lower Cretaceous. So if we read a paper published in 2017, again in Nature Plants by a group of paleobotanists, we can read something that actually sounds remarkably similar to what Tom Harris said in 1956 and in 1960. Ever since Darwin highlighted the seemingly sudden appearance of angiosperms in the mid-Cretaceous, the search for angiosperms prior to the early Cretaceous has been intensive. So far, this search has been unsuccessful. Scattered reports of putative angiosperms from Jurassic and earlier rocks appear to challenge the conclusion made more than 50 years ago that no unequivocal angiosperm remains have yet been described from rocks older than the early Cretaceous. But so far, none of them withstand careful scrutiny. In some cases, fossil material from the Triassic and Jurassic presents interesting features that document extinct diversity among seed plants that may or may not be related to angiosperms. But in the absence of critical details or knowledge of other parts of these parent plants, currently precludes their assignment to angiosperms. In other cases, for example, many of the fossils discussed above, interpretations of angiosperm features generally in very poorly preserved fossil material are not credible. What is needed is the kind of evidence now available from the Aptian onwards of unequivocal angiosperm stamens and carpels. So they're basically saying the same thing as Tom Harris. We've looked very hard for angiosperms before the Cretaceous, and there have been many claims to have found them, but on close examination, none of these claims really hold up. By contrast, within the Cretaceous, we're getting a much better and better picture of the angiosperms that were present, and to some extent, the angiosperms have been pushed back a little bit within the Cretaceous by these new discoveries, but it's been possible to assign these to modern families in some cases. And so there's a real puzzle here. The molecular data is suggesting angiosperms are older. The fossil data is really suggesting that angiosperms are quite advanced in the early Cretaceous. But where are these fossil angiosperms before the Cretaceous? And as Tom Harris said in 1960, we want early angiosperms urgently, almost as a thirsty man wants water. But yet, after 150 years of hopes and disappointments, what Tom Harris was saying back there in 1960 in the middle of this story is essentially still true today. So Darwin's abominable mystery is still very much with us today in 2021.